All right, so we're diving into cancer today. And
Yeah.
you weren't kidding around with these sources.
Oh, no.
NCBI Bookshelf,
Yeah.
National Cancer Institute.
We're going deep.
Yeah, we're not messing around.
No kidding.
So,
Okay.
all right.
Where do we even start with this?
Well,
What actually is cancer?
Yeah, that's the...
It's not like a cold, right?
It's not like catching a cold. No,
You can't just like catch cancer?
no, it's not a single thing you catch. It's more like...
Yeah.
It's like a category of
Yeah.
like cellular uprisings, where cells just decide to
Little
break all the rules.
Okay.
We're done with the rules.
So rules of like
Yeah.
normal growth
Exactly.
and just how a cell should behave.
Exactly, like cell behavior.
Okay.
Totally. Which, I guess that kind of leads into this thing you always hear about, benign versus malignant.
Yeah.
Like, I feel like I should know this, but
Right.
why is one scarier than the other?
Well, I always think of it kind of like this. A benign tumor is like that friend
Okay.
who comes to visit and stays a little too long.
Oh, I know that friend.
Yeah, exactly right. You're like, oh, this is a little much, but they're ultimately harmless. You know what I mean?
Oh, okay.
A malignant tumor,
Yeah.
that's like that guest who comes over and throws a wild party,
Oh, no.
invites the whole neighborhood.
Yeah.
And then some of those neighbors decide they like your house better
Oh, no.
and start trying to move in.
Oh, gosh.
So it's like,
That's a visual.
it's the invasion, the spreading
Yeah.
that makes those malignant ones so dangerous.
Yeah. Okay, so malignant equals cancerous.
Exactly.
Benign is not.
Benign, we could usually live with, right?
Mhm.
It's those malignant ones that are the real troublemakers.
And so that's where you get into these types of cancers, right? Because,
Yeah.
I mean, you hear about so many different types.
You do.
It's kind of overwhelming.
Yeah, and it can be a huge variety because almost any cell in your body can become cancerous.
Oh, really?
Yeah, but there are three main categories we talk about.
Yeah.
Carcinomas, sarcomas, and then leukemias and lymphomas.
Okay, break those down.
Okay, so carcinomas,
Yeah.
they're like the frontline rebels.
Okay.
They start in the cells that line the surfaces of your body, so your skin,
Yeah.
the lining of your organs, things like that.
Oh, okay.
So they're kind of the most common troublemakers, I'd say.
I guess that makes sense. Those areas are exposed to a lot, right?
Exactly.
Exactly. What about sarcomas? Those always sounded kind of extra scary to me.
Sarcomas, yeah, they're less common, thankfully.
Okay.
But they involve your connective tissue, so like your bones, muscles, cartilage, the framework.
So that's how they can really mess things up.
Exactly. They can really mess with your body's structure.
And then leukemia, lymphoma, those are the blood cancers.
Yeah, those originate in your blood-forming tissues and your immune system.
So they don't like form solid tumors.
Often they don't, right?
Huh.
It's more like a buildup of abnormal cells in your blood and bone marrow.
It's like the system itself is rebelling.
Exactly, like a rebellion from within.
You know what's interesting to me? Why is cancer more common as we age?
Oh, that's a great question.
Is it just that our cells get old and tired and start making mistakes?
That's a good way to think about it. But it's not so much about being tired.
Yeah.
It's more like accumulating hits to your DNA over time.
What does that even mean?
So every time a cell divides, there's a chance for a tiny error, a mutation, to slip in.
So it's like wear and tear,
Exactly.
but on a microscopic level.
Yes, exactly.
And those little errors add up.
They do. And,
Yeah.
our bodies are amazing at repairing that damage.
Yeah.
But over time, those hits can accumulate, and it just makes it more likely for a cell to go rogue.
Oh, that makes sense.
Yeah,
So aging is a factor.
it is.
But I'm guessing there's other things that contribute to those hits in the first place.
Oh, there are. There are a lot of things that contribute to those, and that's where things get really interesting.
Okay, so we've got these cells, these kind of rebellious cells that are breaking all the rules,
Yeah.
but it's almost like they've got these superpowers
Right.
that make them different from normal cells.
Exactly. Yeah, they've got these tricks.
What's up with that?
And one of the biggest ones, right, is this uncontrolled growth.
Yeah, that's the thing everyone always hears about with cancer, right?
Right.
The cells just growing out of control.
It's not just that they're dividing faster.
Oh,
It's that they completely ignore the signals
really?
that would normally tell a cell to stop dividing.
So, like, how does that even work? Are they just like...
Well, think of it this way.
Okay,
Imagine you're on a crowded subway car, right?
packed in like sardines.
Exactly. It's rush hour. You're packed in like sardines.
Exactly, you're packed in like sardines.
Nobody wants to make eye contact.
Mm.
Right. Nobody wants to make eye contact. Everybody's kind of like trying to shrink themselves.
Yeah,
Normal cells are like those mindful commuters.
okay.
They sense when there's no more room and they stop dividing.
They don't want a crowd.
Exactly.
Cancer cells are like, whatever, I'm piling on.
They're shoving their way in, ignoring everybody's personal space.
So rude.
No cell etiquette.
None whatsoever. And it's not even just the crowding, right?
Right.
I was reading that some of these cancer cells can actually make their own growth signals.
Yeah, that's another one of their tricks.
It's like they come prepared.
Right. Imagine if you're on that subway car and people start handing out free pizza.
Oh,
Flyers.
no.
Right. Suddenly, everybody wants to pile in.
Chaos. Absolute chaos.
It's like they're creating this constant signal to divide, even when they shouldn't. They're hacking the system.
Exactly. They're master hackers.
And speaking of hacking the system, there's this whole thing about adhesion issues, right? Like, they don't
Yeah,
respect boundaries.
So the rebels, they don't respect the boundaries.
Oh, no.
You know, the signals that keep normal cells in check, cancer cells are like, I don't care. I'm out of here.
Oh, gosh.
They pry open the doors of that subway car.
Between stops.
Between stops, exactly. They hop off. They don't even know where they're going.
That's terrifying.
Right. And that's what metastasis is.
That's how it spreads.
That's how it spreads.
Oh, that is terrifying.
Yeah.
Okay, so we've got the uncontrolled growth, making their own signals, not respecting any boundary.
Right. And they just keep getting worse.
What else can they do?
Well, they also have this thing about differentiation.
Normal cells, they have a job, right?
Like in a factory.
Exactly. They're specialized workers in a factory.
Everybody knows what they're doing.
Everyone's trained for their task.
Yeah.
Cancer cells, they're like, we refuse to specialize.
Oh, no. That's how you get nothing done.
Exactly. They're just making more workers instead of doing any work.
The factory's completely useless.
The factory shuts down.
So they're multiplying like crazy, but they're also not pulling their weight.
Exactly.
Not mass.
They're just causing chaos. And on top of that, they figured out how to avoid death.
You're talking about apoptosis.
Apoptosis, yeah.
I remember reading about that a little bit.
That's like the body's way of taking out the trash, right?
Yeah, like
Yeah.
if a cell's damaged, it's like, okay, time to go.
Exactly.
Self-destruct button.
Exactly. But these cancer cells, they figured out how to disable that button.
No way. So they're basically immortal.
Well, not exactly immortal, but they've become masters of evasion.
So sneaky.
They're hijacking the system.
They're like supervillains.
Right, they've got all these tricks up their sleeves.
It's kind of fascinating.
It is fascinating in a terrifying way.
Yeah.
But the good news is, if scientists can figure out how these superpowers work,
Yeah.
maybe we can find a way to neutralize
Yeah,
them.
totally. Speaking of scientists, you mentioned this thing earlier, the focus assay.
Oh, yeah.
What is that all about?
So it's this really ingenious technique, and it actually lets scientists see cancer cells in a petri dish.
Wait, really? You can like see them becoming cancerous?
You can see them transforming, yeah.
Yeah.
Well, remember how we were talking about how cancer cells lose that contact inhibition?
Yeah, the whole subway car thing.
Exactly. So in the focus assay, the normal cells, they grow in a nice organized layer.
Okay.
But the cancerous cells, they start forming these clumps.
So you can literally see the difference.
You can literally see the difference just by looking.
That's wild. So by studying them like that, scientists can figure out
Exactly.
how it develops?
What might trigger it,
Yeah.
how to stop it. Yeah.
That is so cool.
It's a really powerful tool for researchers.
Okay, so we've covered a lot of ground here.
We have.
But before we move on, you mentioned earlier being interested in estrogen
Right, yeah.
and cancer.
That's a whole other can of worms.
It is a whole other can of worms, but we've got to open it.
We do.
So estrogen and cancer. It's like you see it everywhere.
Right.
But it's always kind of confusing.
One of those things, right?
Yeah.
Like, is it good? Is it bad?
Yeah.
Yeah, it kind of depends.
So where does it fall? What's the deal with estrogen?
Well, estrogen is a hormone.
Okay.
And like a lot of things in the body, it's all about balance, right?
Yeah.
Too much of a good thing.
Right.
And in the case of cancer, it can act as what we call a tumor promoter.
Oh, yeah, we touched on those a bit earlier.
Wow.
So it's not like they directly damage the DNA.
No.
Like those carcinogens we talked about. But
They're not the ones causing those initial hits.
yeah.
But they can make an existing problem a whole lot worse.
Okay, so how does that work? What's a good way to think about that?
Okay, so imagine you've got a pile of dry leaves, right? And this is your precancerous cells, let's say.
All right, I'm with you.
A single spark might not do much.
True.
But if somebody comes along and dumps gasoline on that,
Oh, no.
suddenly you've got a raging fire.
Big problem.
That's kind of what estrogen can do in certain situations.
So it makes it worse.
It can accelerate the process.
But it doesn't actually cause the problem in the first place.
Exactly.
It just throws fuel on the fire.
Exactly. It's all about context.
Okay, so where do the carcinogens fit in then?
Right, so those carcinogens, they're the troublemakers.
They start the fire.
They're the ones causing those initial hits to the DNA.
Okay, so you've got the initial hit, maybe it's radiation, chemicals, something like that.
Right, viruses, all sorts of things.
And then estrogen could come along and be like, let's make this party really wild.
Exactly. It's rarely a single event that leads to cancer.
It's like a chain reaction.
It's a whole series of unfortunate events
Wow.
that send a cell down the wrong path.
So complex.
It is, but that's why understanding that multi-step process is so important.
Especially for researchers.
Exactly.
And speaking of researchers, we talked about this idea of in vitro research.
Right.
What does that even mean?
So in vitro, it just means studying cells outside of their natural environment.
Oh,
So like in a petri dish.
so it's like a controlled setting
Exactly.
where they can really look at what's going on
Exactly.
without all the other chaos of the body.
It's like taking the cells out of the body and putting them under a microscope.
That's kind of amazing.
Yeah.
You can even do that.
Yeah, and that's how techniques like that focus assay we talked about
Right?
can be so powerful
Yeah.
because you can literally see these cells transforming.
That's so cool.
Yeah, it's really incredible.
Well, I've learned so much today.
Me too. It's been a great discussion.
This was a really fascinating deep dive.
It really was.
I feel like we really unpacked some stuff today.
Yeah, absolutely.
And hopefully our listeners got a lot out of it too.
I hope so too. Knowledge is power. Right. The more you know,
Yeah.
the better equipped you are to make good decisions.
Couldn't agree more. So to all our listeners out there, thanks for joining us for another deep dive,
Thanks, everyone.
and we'll catch you next time.